Alright, here we go. 4-1 polynomial functions. How are n behaviors different for even versus odd function? A power function is any function in the form f of x equals ax raised to the n power, where a and n are non-zero real numbers. A is the leading coefficient. Leading coefficient just means the number in front of the biggest exponent. The variable in front of the biggest exponent. And n is the degree. Alright, example 1. Can someone get that, please? Describe, we're never going to make it through this lesson at this rate. Describe the end. Alright, thank you. Can you take those shoes to wrestling practice today? Liam says you're lame and you should do it.
Please pardon the interruption.
Oh my gosh.
Students, we have Mr. Ryan for your English.
Hey Bella. Thank you. Great job last night.
We have Mr. Ryan for English.
We're never going to make it through this lesson.
Also, the email for the Rogers and Dr. Rogers has been. I have for now.
Yeah. Alright, describe the end behavior of f of x equals negative 2x cubed. I personally am a visual learner, so I need to see what that graph looks like. So I'm just going to draw a little graph. It's nothing special. It's nothing fancy. Alright, negative. So negative means it's going downhill. X cubed means it's going in the opposite direction. So it should look something like this. Probably not exactly like that, but something similar to this. Alright, it's a negative, so it's going downhill. It's an x cubed, so it's odd. So it's going to be going something like this, and it wants to know the end behavior. So end behavior means as x goes to the left. Yes, but not yet. That's like a couple sections ahead. As x, I said left, I meant right. As we go to the right towards positive infinity, what's happening to our graph? Is it going up towards positive infinity or down towards negative infinity? It's going down. So my y values go down towards negative infinity. Now, as we go to the left, as x approaches negative infinity, y, does it go up or does it go down? It goes up towards what? Positive infinity. There you go.
So we're looking at both of them?
Yep. You got to go right. Start at the center, go right. Start at the center, go left. As you go to the right, it goes down towards negative infinity. As you go to the left, it goes up towards positive infinity.
Okay, I got it.
All right, next. I have no idea. The degree tells you the maximum. The degree tells you the maximum number of times that a graph can intersect the x-axis. And I'm going to, once again, being a visual learner, I'm going to draw a little graph. And it says the degree tells you the maximum number of times that a graph can intersect the x-axis. So if I had an x squared, How many times can this cross my x-axis? Twice. The maximum amount of time, no matter how I draw a parabola, it can only cross a maximum of 2 times. Let's say I had x cubed. The maximum amount of times this can cross the x-axis is once, twice, 3 times. All right, graphs have one less turning point than its degree. I guess we should know what turning points are. Turning points are where the graph changes direction. All right, for example, an x squared is a parabola. It crosses the x-intercept twice, but how many times does it change direction? 1 less than 2, so it only changes direction once. This is a cubic. It changes directions, it changes directions 1 less than 3, so it's going to change directions twice. It changed directions once here and once here. That's twice. Not that difficult. All right, grab your little paper, please. The one with the little graphs on it. I was getting there. I wasn't going to...
If we can glue these in.
Yes, you should. Actually, I think I have a glue stick we can pass around.
Do you have scissors so we can like cut them and make them smaller?
Yep, catch. I'm still looking. Alright, so use it and pass it back, please. Use them and pass it back, please. Use them and pass them back, please. Alright, positive and even. A positive means that, let me give you an example of a positive even. X squared. This right here is positive. This is even. So it's a positive x to an even. It must open up. Both sides must open up. It could look something like this. It could have a ton of little squiggles in it at the bottom, but any positive x to the even must open up. So, what would be true if it was negative x squared or x to the 20th, whatever? This would be a negative x to the even. Instead of opening both up, it would have to both open down. I thought I had another glue stick, but I don't see it. All right, Conversely, this is a positive x to the odd. So let's say we had x to the third. It needs to start in quadrant 3 and end in quadrant 1. It has to go in that direction. I'd like to think odd go in opposite directions, odd or opposites. Think of this as your money. If your money's going up, that's a positive, correct? It starts low and it goes up. So, or your grades, that's a positive. But what happens if you have a negative x to the odd? What are happening to your bank account or your grades? They are going down, which is not good. That's no bueno. Speaking of no bueno, no, I'm not going to restart my computer right now. Yes, but not yet. Right there. I didn't know you were here this early in the morning. Alright, we want you to CCC immediately, so for 5 minutes. You can get the notes and come back. All right, moving on. Example 2. I have a little graph, nothing fancy, nothing special. It's a straight line going up. So what I want to know is what is the degree and what are the turning points? How many turning points are there? So I think this would almost be easier if you worked backwards. How many times does a straight line change direction? None or 0. So the degree is 1 more than the turning point. So if the turning point is 0, what's my degree? It's 1 more than your turning point. So it's 1. So my degree would be 1. So this would be like y equals x plus 2. Y equals x plus 1. If we were to actually x plus 1. Ooh, I saved it. All right, let's say we had another one.
Would you put y equals x plus 1?
Yeah. We really didn't need to do that. I was overachieving. Sorry. It happens sometimes. All right. How many times does this parabola change direction? Once. So my turning point was once. The degree is 1 more than the turning point. So if the turning point is 1, the degree is 2. And doesn't that make sense? That would be a negative x squared because it's opening down. All right, just to try and make sure we understand this. Turning is where it changes direction. Turning point's where it changes direction. So on this last one, how many times has it changed directions? Once, twice. So that means the degree is... There you go. It could be a squiggle line. All right, ladies and gentlemen, let's get out this thing. Time waits for no one. Don't tell me what to do. You're not my daughter. I don't think. Alright, who are we waiting for, Annalise? I don't even know who I'm talking to. Jonna? I just knew it came from that direction, and it wasn't Crystal, and it wasn't Jonah, so. Yo, Joe. All right, let's fill out this little form here. So smart. What? All right, let's fill this out. First of all, is there an X in this first box here? No. No, so my degree is 0. My degree is going to be 0. If you're not sure what a 0 is, look at your focus. I'm sure there's plenty of them there. Oh, wait, this is Algebra 2 honors. There's probably not many. Yes. Also, since this is only a number, there's no letters, this is called a constant. How many terms, this is called a term, how many are separated by plus or minus? Alright, so there's 0, so there's only one term. That is called a term, and there's only one of them. Alright, besides everybody who's ever been to Disney World. Alright, that's a rhetorical question, you don't need to answer. When you park in the lot to get to Disney World, the main part, you can take the pirate ship. No, not the pirate ship. Hold on, that's what I want, but not yet. No. You can, from the parking lot to the park, you can take the ferry. There's another name for it. The boat. The Magic Kingdom. The boat. You can take the boat, or you can take the what, Jonah? Why do they call it the monorail? Because there's only one rail. It's not like a train which has 2 rails. There's only one, so that's called a monorail. Well, there's only one term here, so this is called a monomial. Yeah, it was. I still can't think of that.
It's like monomial, and then there's like trinomial.
You skipped one. Oh, paddle boat. That's the word I was looking for. You take the paddle boat to get from the parking lot to the, yeah. But it has a big paddle in back, so it's... All right, let's move on. We're moving at the speed of erosion. All right. Yeah, science joke. All right, what is my degree? What's my exponent above the x?
0.
No? 1. Anything raised to the 0 power is 1. So it is 1. My degree is 1. If I was to graph this, what shape would it be? A straight
line starting at 4.
Well, it crosses at 4. You are correct. So this is a linear graph. What's the root word of linear?
Line.
I was hoping someone would have said ear. Someone said that before. Scary. All right, how many terms are there? 2. So think of biplane.
Binomial.
Bicycle. Biped. What's a biped? You're a biped. You walk on 2 feet. Binomial.
Told you, Mr. K.
Bicycle. Binoculars. You have 2 lenses. Good job. All right, next. I don't know if biology works. Because bio's the prefix, not bi. Why is it what? That I don't know. That's an excellent question for a science teacher. Oh, we haven't been interrupted in 2 minutes. It's fine.
Unless it's Jonah asking a question.
Oh, Valentine's back. That's acceptable interruption. Wow. Haters.
I'm interrupting.
Hey, ask Miss Pico. She's all knowing.
Why is monomial the one for that? Why is it not uni?
Why is it uninomial?
You don't know?
Mono means one, is all I know.
So does uni.
I know.
What's that? It's the eighth mystery of the unit.
It must be Greek.
Yes, blame the Greeks.
Do you have any couple blue passes I can borrow? I went to go get some and then I forgot. And I sent a kid and Miss Joe forces, I can't have a kid.
All right, moving on. What's my degree on this one? 2. What is a 2? It's not a parabola, it's a quadratic. How many terms are there? Just one. There's nothing separated by plus or minus, so there's only one. So once again, this is a monomial, not a uninomial. Noah? Noah's in front. Alright, what's my degree here? I think that's a 3.
Well, there's 2 X's.
Yeah, but you go by the highest. Alright, so this is called a cubic. Yeah, why? Yeah, hold on. How many terms are there? So this is a trinomial. Trinomial. And 3 is as big as it gets. After 3, they don't call them certain things. They're general.
Quadromial.
No. Alright, so this one, the biggest number is a 4. Do we have any? Oh, Audrey's in culinary. How many quarts are in a gallon? 4. How many quarters are in $1? 4. So this is called, since it's raised to the 4th degree, it's called a quartic. There's only 2 terms, 1, 2, so this is a binomial. Yes. Because you go use the biggest number, the biggest exponent is your degree. Good question. All right, 5. Does anyone know what 5 is? What is 5 instruments playing at one time, or what happens when a baby or 5 babies are born at one time? What do they call it?
Too many.
What'd you say? Quintuplets is correct. So this is a quintic. Good job back there. How does quintic sound racist? New rule for Jonah. You're to be seen and not heard for the rest of today. I will in a second. Alright, after 3, they just call them polynomials. Poly means many.
Yeah, 5 kids at once, that's too many.
I can't even imagine.
Court, please.
Good job, I'm proud of you. We're not done. We have one section left. We're almost done. Fill what in now? I'm so confused. Yes, fill in your notes now. Ready? You can glue it in now, yes. Just don't eat the glue, please. Get your hands to yourself, please. I'm about to do a magic trick. I'm going to make Jonah disappear. You're not used to her complaining yet?
No, I am. You're being I've been sitting.
Alright, some graphs will have an absolute, max, or min, no owls in math, while others have a relative max or min. We have one more sentence left, 2 graphs, and we are done for today.
Are we done?
We have one more sentence, 2 graphs, then, maybe that was the then that confused you.
Yeah.
We are done for today. A graph can only have one absolute max or min. What would we call a graph with with an absolute minimum and a maximum?
Final.
A line.
A circle. Seriously, it'd be a circle or
Kind of like a ray. Circle.
a circle, or it could be an ellipse. It could be an oval. But that's the only thing that could have a. If you had a max and a min, it would have to be something like that.
Triangles?
Maybe, but that's not a function. A triangle's not a function. Also, a circle's not a function either. A graph can only have one absolute max or min, comma space, but can have multiple relative max or min. All right, Kyla, the sentence is done, so we have 2 graphs left, then we're done.
Hey, you
All right.
only said sentence.
Yeah, and you interrupted me before that, so it didn't matter. I wasn't done. All right, 2 graphs. 1, 2.
We're done.
I don't see a graph. I see a coordinate plane. I don't see a graph on the coordinate plane.
What if I just write one line?
What if monkeys fly out of the cabinet? We'll worry about it when it
That would
happens.
be so amazing.
Especially if they took you back to the Wicked Witch. Not you. Yeah, Jonah, see, not her.
Oh, I did it. I did not.
All right, question. We're just about done. Does a graph go any lower than this point right here?
They go low.
No, so that right there is considered an absolute minimum because that is the absolute lowest point on the graph. So that right there is the absolute minimum. All right, 1 graph left. 3 labels, and we're done. I'm sorry, you want me to add homework?
No.
Do you want me to add some McGraw-Hill online stuff?
No, Mr. Katie, you don't like McGraw-Hill.
I hate McGraw-Hill.
No, but he'll do it on spite.
Exactly. Won't hate it as much as you'll hate it. All right, is there an absolute highest point to this graph?
Yeah.
Right here?
Yeah. No.
No, right here. So this point right here is your absolute, not minimum, but absolute max. Does this graph have an absolute minimum?
Yeah.
No.
No, because it goes down forever.
Yeah.
All right, we do have a relative maximum. This is not the highest point on the graph, but it's the highest point in quadrant 2, correct? So that is a relative max.
Okay. And then the
This is the lowest point of the graph, but not the absolute lowest point. So this point right here is a,
relative min.
guess what?
We're done.
Yay.
Yes and yes.
Yay.
So smart.
Yes, you is. Oh, hold on. Bad grammar there.